My name is Becky Weiss. I am an engineer on the AWS Identity and Access Management team. And the good news that I have for you is that while the set of AWS services and features is indeed vast, the set of things you need to know to secure them properly is not. There are really only a relatively small number of fundamental concepts and patterns that you have to master. And these are IAM for permissions management, VPC, virtual private cloud, network security features for network security. These are the two services whose patterns you need to understand in order to do anything securely in AWS. And once you learn how to spot the patterns, once you learn the fundamental concepts, you're going to be able to secure everything in AWS. These are patterns that repeat across our entire set of offerings. So that's what we're going to talk about today. And I believe that in the next 60 minutes, I can get you to the point where you know how to read and write permissions, you know what these permissions are capable of doing, and you know how to use the network security controls available to you. So that's what we're going to do here in the next hour. So of course, the first thing you need to know if you're going to secure something is where it is, right? You know, this graphic here of a house that looks weird because it doesn't have any entry points. I can't tell you how to secure that house because I don't know where its points of entry are. All right, let's draw in some points of entry. Well, that's a door. It opens. I probably need to secure it. Well, taking this analogy into the AWS world, in order to secure what you're doing in AWS, you first are going to need to know where it is. Well, in AWS, those of you who have been using AWS already, you know that you're going to you have one or more AWS accounts. That's a unit of ownership of things, of resources in AWS. Now, if you've used AWS, you also notice that almost all of our services, with the exception of a couple services that only make sense globally, is in a physical location, an AWS region. At this very moment, we have 19 regions all around the globe. They're physical locations, and they're truly isolated from one another. Like an instance of a service in one region shares nothing, shares no infrastructure, shares no data with the instance of that same service in another region. So to make things simple here, I'm going to consider just one region, although you have all of these 19 regions available to you for global reach. Okay, so we got a physical location, an AWS region. Now, to subdivide the physical location even more, each of our regions is divided into multiple availability zones. Availability zones has the name availability. It's a core concept for when you're deploying high availability services on AWS. That's not what we're going to talk about here. For the purposes of this discussion, availability zones are kind of a further division of where your resources go. Now, of course, these are your resources, your infrastructure, so they need to go in a network. And in AWS, you control the network. This here that you're looking at, this is a VPC, a virtual data center in the cloud. You control pretty much every aspect of it. Connectivity, IP addressing, so we've chosen this IP address range. If you don't read the networking ease, that's called CIDR notation. It means IP address starting with 10.0.something.something. So this is your VPC network in a region. It's owned by your AWS account. And of course, if you're going to deploy infrastructure, it needs to go, each resource needs to go in a particular availability zone. So the subnets, the subnetworks are how you subdivide your network so you can be specific about which availability zones your resources go into. So now that we have all of that, now we can have some resources. We can have, for example, EC2 instances, virtual machines in the cloud. These run in your subnets, in the availability zones, in your network, in the region that you've chosen to run your VPC in, and all of this owned by your account. Now, EC2 instances EC2 is only one of many AWS services that runs infrastructure in your network. Really, it's anything in AWS that's managing infrastructure dedicated to you. One example is our relational database service, RDS. You deploy that inside your VPC. The databases themselves are managed by RDS, but the infrastructure is running in your network. Lots of other examples. For example, if you have a Windows workload and you're using our Managed Active Directory service, Your domain controllers for that service will run in your VPC, and so on. There are a lot of other examples like this. Now, when you're running workloads in AWS, infrastructure that's either managed for you by AWS or that you're running yourself in your VPC goes in your network, which means you can use network security controls on them. But you'll also be interacting with AWS services that are not in your VPC. The resources are in your account, in your region, and you own them and control them, but they'll appear not to be in your VPC. For example, almost everybody here is going to be storing their data in Amazon Simple Storage Service, S3. You know, buckets where you can put objects, get objects, store your data in the cloud. And lots of other services also have this characteristic of they're owned by you and controlled by you, but they're not in your VPC. For example, SQS, if you're using a queue for your applications, that's not going to be in your VPC. A DynamoDB table, our NoSQL database, also not in your VPC. Lots of other services work this way. The services in this category, these are services that, you know, we don't call them serverless, you know, because serverless is kind of a new thing. But essentially, they are serverless. They're highly scalable services running in Amazon's network that you just make web API calls to. So now the first question is, OK, some things are in my network, some things are not in my network. I think I'm going to be using different tools to secure them. So how do I even tell which is which? I just have this long list of AWS services that I'm using. Well, there's a number of ways you can do it that you can tell where your resource is running. The easiest way, one way that I find is as you're provisioning the resources, if you get asked about a bunch of VPC things like security groups and subnets, we'll talk about both of those later. That's a hint that you're about to run something in your VPC. But another thing you could do is just resolve, these are all services that you access across a network. You get a DNS name for any of these, just resolve that DNS name. For example, you're going to talk to that database from inside your VPC. So resolve it, you're given a DNS name for it, an endpoint. Resolve that. You can see that's an address in your VPC, so I know that my RDS database is indeed in my VPC. Whereas if I were going to be talking to SQS to use my SQS queue here, well, the DNS name I have for that is of the general SQS service. I resolve that, that's not in my VPC. So that's one way to tell the difference. Now, it's regardless of whether the resource is running in your VPC or not in your VPC, it's under your control. And we're going to talk about both cases. So this is how it breaks down. So the first thing you need to understand, the thing that I'm about to secure, is it running in my VPC or not? It either is or it isn't. And depending on whether or not it's running in your network, you either do or don't use network security controls on it. And in all cases, you use identity and access management permissions, which can get for some services very fine-grained, can give you extremely fine-grained and flexible control over your resources. This is what we're going to talk about here. So you see that IAM thing, it seems to be useful across the board for securing everything. So let's start there. OK, so what is IAM? IAM is our identity and access management system. The I stands for authentication, and the AM stands for authorization. And this is used across AWS. All of our services support permissions with IAM. This is how you secure access to any AWS resource that you have. OK, well, if you think about AWS, the WS stands for web services. Everything you do in AWS is done by calling an AWS web API on the service that you're trying to work with. Now, it's a web service. You're creating and just deleting and modifying resources. So you need to be authenticated to call that API. AWS, the service that you're calling, needs to know who you are. So first, let's talk about who you are in AWS as you make an API call. Well, one thing you could be as a human user. In fact, if you've ever logged into the AWS console with a username and a password with some long-term credentials, or if you've ever used that access key ID secret key pair, and you've configured your command line interface or your SDK with those, if you're using long-term credentials, you're an IAM user, and that's typically for human users. So that's one kind of identity you can have in AWS. How many of you here are human? How many of you here are robots? Yeah, there's always somebody. This is reInvent. Well, the other kind of identity you can have in AWS, the other thing you could be in AWS is a robot. And by that I mean an application, an automated process, something that isn't a human user clicking around the console or making API calls in the CLI. For those, the identity that we use is called an IAM role. And all of our platforms on which you can run your own application code. So I have up here EC2, an EC2 instance that I might be running an application on, or a Lambda function that I might have deployed my code to be run serverlessly in AWS. All of these support running under an IAM role. As you're setting up the Lambda function, as you're launching the EC2 instance, you can and you should designate an IAM role, an identity for it. Now, the great thing about this, as a security practitioner, is that IAM roles, unlike the IAM users that work with long-term security credentials that someone just needs to be really careful about, IAM roles use short-term security credentials. And the great thing is these platforms, EC2, Lambda, Fargate, ECS, a whole long list of them support IAM roles. And the application code that you write no longer has to handle any credentials. It just runs as the identity of the instance or the Lambda function that it's running at and has the permissions associated with that role. So this is great. That means your application developers aren't trying to smear secrets around all over the place and keep them safe. Nobody ever looks at secrets. They're handled behind the scenes by EC2, does all of the work of retrieving, making available, refreshing these short-term security credentials. And then, once, the application code just goes and accesses this dynamodb table in the picture here to do what it needs to do. One thing that I'll just mention is, in fact, you'll see AWS services that themselves modify AWS resources that you have. I have up here application auto-scaling. It's a handy feature that if you're using DynamoDB, it will scale up and scale down the provisioned I/O based on observed demand. And that's great. Now, if you think about that, that's an automated process running that needs to change a resource, your DynamoDB table. And in fact, if you look under the hood, which I encourage you to, as practitioners, that's a great way to learn about things. If you look under the hood, you'll see that AWS application auto-scaling will itself create a role for itself to run under so that it can do what it needs to do with your DynamoDB table. There is one other case for roles. I'm just going to mention it. It's kind of an advanced topic, but for those of you working at enterprises who have your users in a corporate directory, this is a good thing to know about. You can look it up later. It's called identity federation. Those are the words to look up. If your corporate directory is something like an Active Directory, supports SAML, you can set it up so that your users authenticate to the corporate directory, and then, then we manage all this machinery. This SAML token will then gets passed into AWS, which AWS will exchange for a role. Your administrator will set up the mappings of groups in your Active Directory to the various roles that people should end up as. And again, the short-term credentials are managed for you. So this is for the human corporate robots. And the umbrella term for both kinds of identities, we've been talking about identities. IAM roles, short-term credentials, use them whenever you can. They're always the better one from a security perspective because of the short-term credentials. And IAM users for direct human access. So that's who you are. In fact, I'm going to go under the hood, into the details a little bit. You don't need to know what I'm about to tell you, but it might help your understanding of how calls into AWS are actually authenticated. I'm going to give you the example of an IAM role with its short-term credentials, calling an API in DynamoDB, list tables, show me the tables that I have. And we're going to kind of look at what that authenticated request actually looks like. I'll show you the HTTP headers here. Again, you don't need to know this because the console, the command line interface, the SDK, it's all doing this for you. You don't need to know how to do this. But I'll point out to you that the authorization header here has the non-secret part of your credential pair in here. This is who I'm claiming to be. And then the key part here, an HMAC signature, produced client-side with the secret part of your credential pair. So you have to have that secret in order to produce a valid signature. The signature covers the entire request, so it can't have been tampered with. And this gives AWS everything it needs to be able to determine that, yes, it was in fact this role who made this request exactly as I'm seeing it. So you don't need to know this, but sometimes I find that it helps to take kind of a peek under the hood, look at the machinery. But back to reality. You have an identity. You've authenticated to AWS. Of course, that's only half the picture, right? You are who you say you are, but are you actually allowed to make that call to DynamoDB list tables or whatever you are going to do? And that's where IAM policy comes in. IAM policy is used in multiple places across AWS. It always comes up in the context of securing something. The most common use of an IAM policy is you attach it to a principal, to a role or a user, and it's a statement of what they can do. We're going to learn how to read and write these policies. They're written in JSON, and in many cases they're self-explanatory, just a couple patterns to understand, and you'll be able to do the rest with documentation. So IAM policy matters everywhere in AWS. All API calls, with the exception of those that are explicitly unauthenticated, and there are very few of them and it's very obvious what they are, every call to every AWS service is authenticated and authorized. So first, it checks who you say you are, and the request is validly signed. And then it looks at the policy, at all of the policies that are relevant to the request. But here we're going to talk about the policies associated with the caller, with the principal, and figure out whether it says we're allowed to do what we're going to do. So we're going to dive into what makes up a policy, how to read and write it. But the first thing I wanted to call your attention to, AWS on the IAM console actually maintains a curated set of managed IAM policies. You see here I'm searching for the ones that have to do with Dynamo. They have friendly names that kind of explain what they do. You can actually go, I recommend using these for human users because they've got all the commonly used permission sets in there. One thing you can do is you can actually go and look at the policy written for each of these. That's a useful thing to do if you're just trying to learn about kind of what permissions do I need to be a DynamoDB full access. What permissions do I need on which services? It's actually a good learning tool as well as being handy shorthand for your human users. Okay, well let's talk about how to read and write an IAM policy. This is a very simple policy I'll put up here. Let me point out different aspects of its anatomy here. There's an effect clause. It'll say either allow or deny, which means what you think. There's an action. In this case, what is this person allowed or disallowed from doing? You'll notice that we support wildcards here. So this notation here means all APIs in DynamoDB are allowed. And then finally, there's a resource. You can see that also supports wildcarding, and that indicates what can they do this action on. Okay, so the English translation of this policy is whoever has this policy, they can do anything they want in DynamoDB within the account. Of course, you can't attach a policy to a principal that gives it permissions outside the account. So they can do DynamoDB inside the account. Now, your security people here, you might be thinking, that doesn't sound very least privileged to me. So maybe let's maybe narrow this down a little bit more, and let's think about a concrete example where I'm writing a policy for an IAM role that my application is going to run as. I'm going to put this IAM role on a Lambda function. I'm going to deploy my serverless application to the Lambda function, and I need it to read items from a particular DynamoDB table. I know what table that is. I know what they need to do. So I can be specific about the actions. These are actions in DynamoDB that are typically associated with reading individual items. Okay, so I can read things on DynamoDB, but you know what? I can get even more specific than that. I can specify the resource. I know that they want to get to my table name. That's the name of the table that they want to get to. And in fact, they're going to be doing queries, and that query call is going to be going against the indexes for that table, so I have another wildcard specification of this. If you're wondering how I came up with this, the answer is for the service you're going to be working with, you look at its IAM documentation, and it will tell you how you specify the resources that are relevant for the different actions. So now we have a pretty good least privilege policy here for my application. I can do these specific read API calls, which means I can't go and delete tables because there's no need for my application to do that, and if it's trying to do that, there's a problem. And it's a specific table and its indexes, so it's not accessing all of the DynamoDB tables in my account. This application works on this one table, so that's what he's on. You might be wondering what all this notation here is with all the colons in it. This is an AWS-wide thing. It's called an Amazon resource name, an ARN. You see these for all of our services. I've kind of marked out the different parts of this ARN. It's a fully qualified name in AWS. With all of these fields, it uniquely identifies, in this case, your DynamoDB table. So we can get even more granular than that. For example, DynamoDB is a service that holds data. Now, many of you might be operating under regulations that are concerned with data residency, like where your data lives. We talked about those physical regions all around the globe. You may have particular regions that you intend for your data to be in, and you don't want anybody to accidentally or maliciously use DynamoDB in the wrong region. Well, so AWS IAM policy offers conditions, and there are many condition keys. There are condition keys that are that work across AWS service. You're looking at one of them here. There are also ones that are specific to the service, like DynamoDB can let you narrow down based on what's in the primary key. So there's conditions that are, only make sense for a specific service. But this one here, if I have this permission, it means that they can't accidentally use DynamoDB in any region, but here I said Ohio. So here you're allowed to do anything with DynamoDB as long as it's in the right region. So far, we've been talking about permissions on principles. And permissions on principles, you think about why this might be so, it makes sense. Permissions on that account, remember we said at the beginning, is a unit of ownership of AWS resources. So within the account, the principals that live in the account, the policies can authorize them to get at things within the account. But in reality, it's often the case that you're going to find yourself, especially at enterprises, running across multiple accounts. An extremely common use case for running multiple accounts in AWS is just different environments. You have your production, it's very common to have your production environment in one account, maybe your development, test environments, each in respectively other accounts. Maybe you have yet more accounts for shared services, accounts for science experiments from your developers, and you keep these in separate accounts so that you have no risk of crossing the streams. You'll put those accounts in an AWS organization so that you get a single bill for all of those. Organizations also gives you a couple of management tools for your set of accounts. And when you set up something like this, it's very common to find that while you are using those accounts as a unit of ownership and they're good sort of tight bubbles, perimeters of resources, you do have access patterns where you need to, maybe this application on this EC2 instance running under a role needs to get to data in an S3 bucket from another account. Now remember what we said before. The principal policy for that EC2 instance, it can't just by itself unilaterally give itself permission to that bucket outside the account. There needs to be some other mechanism for doing that. And for that, remember when we talked about IAM policies, we said, well, IAM policies very common to put, you always are putting them on principles, but there are a couple of other places you can use them too across AWS. Well, this is one example of that. So you notice here I have an IAM policy in this picture, but it's not applied to a principal. It doesn't say what some particular principal can do. Instead, it's attached to the S3 bucket. We call these resource-based policies in AWS. About 20 of our services offer them. In S3, you'll see them called bucket policies. And it's IAM policy that's attached to the resource, the bucket in this case. Now I'll show you what that looks like, and I hope by now this is looking familiar. This looks a lot like the policy statements that we were putting on principles, except there's one new thing here, which I've highlighted. There's this principal clause, right? Because this policy is not attached to a principal, and in fact, one of the things that I'm going to want to do on my bucket policy is I'm going to want to talk about who can access me, right? So if you look at this policy, it's saying that role, and you notice that's an ARN of the role in the other account. I say this role in that other account, here's its fully qualified ARN. It can call the specific API it can call as getObject, and I even know the path under me that it's going to be calling getObject on. So now you have the IAM, you have the bucket saying that it can be accessed from this other account. And if you think about it, that makes sense. The bucket is owned by this other account. So something in this account needs to be letting that first account in. So here's how that works when you're doing access to AWS resources across account. First off, the S3 bucket that's trying to be accessed has to explicitly be allowing that other account in some form to get in. And then, as always, the principal who's making the call, the purple role in the top account, has to, as before, have an IAM policy attached to it that lets it do what it's trying to do. Both of these have to be true, or else the access gets denied. Account 1 needs to say, I'm OK accessing data from account 2's bucket. Account 2's bucket needs to say, I'm OK being accessed by these specific roles or this account. Now, as I mentioned before, many of our services, 20 of our services, support resource-based policies. Not all do. For example, DynamoDB doesn't. You can't put a resource-based policy on a DynamoDB table. But for those services that don't, one thing you can always do is IAM roles themselves have resource-based policies. We call them trust policies in our documentation. You might also see them called assume role policy documents. They are, again, short IAM policies that say who can assume this role. So I set it up so that the role at the bottom, its trust policy says it can be assumed by the role at the top. And then my application code running in that EC2 instance in the first account, it'll go assume that role, get those temporary credentials, and use that to access DynamoDB now from inside the second account. So that's something you can always do for cross-account access. Now, one thing I should mention in IAM, there's a lot of details here, but really, as you see, the patterns repeat over and over and over again. And I've mostly been talking about DynamoDB just because it's a great example, but really every AWS service works this way, and the particulars just change depending on what you do in that service. What I'm showing you here is my favorite page of the AWS documentation. This is the most useful documentation, in my humble opinion. AWS services that work with IAM, I've shown you a screenshot below. We have every service listed, showing you what it supports. You click through to that, and what you will get there is you'll be able to see how you specify resources and how you specify resources for the various actions, what service-specific conditions are available to you, because those are, of course, going to vary according to what the service actually does. This is a very useful reference because, again, there's a lot of AWS out there. I think it's safe to say no living human being has memorized the surface of all AWS services now. Maybe that was true a couple years ago. It's certainly not true today. But if you know these patterns, you're going to know what questions to ask. You're going to know what to go looking for as you look at that documentation. So really, you do this with documentation and an understanding of the patterns. Now remember we said, so this IAM thing, it works no matter what kinds of resources you're talking to in AWS. Inside your VPC, not inside your VPC. But if we're talking about things in your VPC, you also, since you control the network they're in, you also have access to the network security controls in your VPC. And we're going to spend the next little bit talking about, not about all of the features of VPC available to you, because there's a lot of connectivity and availability features, but we're going to talk specifically about the tools you have in VPC to secure your workloads. They're actually fairly simple, and they don't require you to have any sort of networking background to grok what they're doing. Really kind of 3 categories of things to know about. Security groups. Security groups allow you to control what traffic flows into or out of different parts of your VPC. Routing. Routing sounds like a networky topic, but it's also a security topic because it lets you create least privilege connectivity. And then finally, to go even further with least privilege connectivity, we have a family of features called VPC endpoints that I'm going to talk about. So first, let's talk about security groups, authorizing only the traffic you expect. Hey, I'm going to tell you, this is the easiest of these 3 topics, and it's also the most powerful. So security groups are actually fairly easy to explain because they're probably aligned with how you're already thinking about your applications. Here's an example workload that you might run on AWS, very, very common. I have a public-facing web service. In other words, my users are going to be, I expect my users to reach me over the internet. I expect them to come from everywhere. I've put a load balancer. This is application load balancer. That's our layer 7 load balancer in AWS. I've put a load balancer in front of it, so that's the front door they're going to be coming into. That load balancer is backed by an auto-scaled fleet of EC2 instances. I haven't shown the auto-scaling group, but it's there. So these instances are running your application code. And as part of what they do, they query a relational database to get some data, form a response, and send the response back up. So this is fairly common. You've probably seen this before. And what I just described to you is exactly the patterns of network traffic that you're expecting here. So let's make it so that we get only the network traffic that we were expecting here. And we do that with security groups. We put a group around each set of things that has like network traffic patterns. For example, I've got this application load balancer. It's going to be listening on port 443 because this is an HTTPS service. And I want to allow traffic in from everywhere. The instances, on the other hand, they're only expecting traffic that's forwarded to them from the load balancer. They're not expecting requests that come from somewhere else. And likewise, the databases, they're expecting traffic from the EC2 instances, not from somewhere else. So how do we do this with security groups? Well, it's literally what we just said here. The security groups, these are inbound security groups, ingress security groups, and they specify what kind of traffic is allowed in. So for example, the group that my load balancer is in, the load balancer the load balancer itself auto-scales behind the scenes. Amazon does this for you. So it might be multiple IP addresses in your VPC. You don't have to worry about that or care. You just say, you put the application load balancer in the security group, and you write a rule that says all traffic, that's the 0.0.0/0, all traffic can send, all sources can send traffic to me on port 443. So I don't have other ports open because I don't need them. I just have this port open, but it's open to everything because that's my intention. If I go look at the security group for the tier of instances here, these instances are all in the same security group. You notice that there's kind of a different sort of looking rule here. They're listening on port 8443, let's say, but the rule is allowing traffic from another group in the VPC. So I'm allowing group-to-group traffic. It's a very convenient way of thinking about this, so you don't have to worry about how all of these layers are auto-scaling. And then finally, the databases are in a similar kind of group, except they're listening on port 3306 because maybe this is MySQL. Now, each of these security groups I showed you, I put only one rule in them. You can put multiple rules in a security group if you wanted to open multiple ports or had multiple ranges of addresses. That's very common. You might have been wondering, okay, you're allowing all the traffic in. I can see how the packet gets all the way down to the database. But what about the reverse direction? Right? I didn't say anything about who I'm expecting, how the return traffic is supposed to be authorized. And that's where the word stateful up here comes in. Those of you with a networking background will probably recognize this. But security groups are stateful, which means that they govern the initiation of the connection. So as long as the connection is allowed to be established, the security groups actually track the fact that this is an established connection and allow the reply traffic without you having to authorize it explicitly. If you do need to go in the other direction, this is less common. Security groups also support egress rules, which works in the opposite direction. If you wanted to limit the outbound connections that your instances or your other infrastructure could initiate, you could do that. Far more common is to do ingress security group rules. And you know what? If this is the only thing you take away from the networking part of this talk, you are prepared to run a perfectly secure network. Security groups work, they're simple, they're powerful, and they do what they say. So you might wonder why I even have these, why she's even going to talk about these other topics here. And the reason why is because it's very common for customers maybe moving from an on-premises environment, or maybe who are in regulated industries, or maybe your own customers are asking you questions about your environment where they want you to show that part of your network is not on the internet. And routing is the way that you do that for least privilege. Okay, so let's talk about routing in a VPC. Remember we talked about your VPC spans the availability zones and you have subnets in those availability zones. Subnets are the unit of a number of things. You can see they're a unit of sub-addressing in your VPC. But significantly here, they're also a unit of routing. Each subnet in a VPC is associated with one route table, and that route table is a simple list of rules that says where packets can go when they leave the VPC. So I'll take away the other two availability zones just to make the picture simpler, but you can imagine a copy of what we're going to talk about in each availability zone. So let's talk about this availability zone, and let's look at the subnet on the bottom here. Let's say I'm running some internal compute job on EC2 instances. Maybe I have an Elasticache cluster, managed Redis running in there. All of this is private data. This data, nothing I'm running in here has any reason to send traffic outside the VPC. Well, if I put all that traffic in the same subnet, I can take the route table for that subnet, and I can give it, route tables come with this one rule, and I haven't added any more rules to it. This rule says in English, traffic that's bound for the VPC that matches that one rule there, 10.0/16, gets routed locally. So traffic sent to the VPC can get there. Notice I have no other routes here, which means if somebody tries to send a packet outside the VPC, either accidentally or maliciously, it has nowhere to go. It gets dropped. So that's great. I can now show anybody who wants to know that the resources I'm running in this subnet are off the internet. There's no way for them to get to the internet, and there's certainly no way for the internet to get to them. Now, of course, a very common and valid use case is you might have things that you explicitly do want to be accessible from the internet. Like you remember that application load balancer for that public service we were running before. Well, that needs a publicly routable IP address. It's in a security group that's open to 0/0, and I need it to have a route both, in and out of there. You may also be running, if your operators require SSH access to your instances, you might be running a Bastion SSH host or a jump host up there. And for that, I'm not showing it here in the picture, but that would be in a security group that would have tightly scoped rules. You're expecting people to get onto the Bastion host, so really only from a few specific IP addresses. But in this case, I really do want access to the internet from this part of my VPC. So for that, you create an internet gateway. That's something you create with a VPC API. You create a route to it. Your route is going to look like this. See, notice that second route here, 0/0, is being sent to the internet gateway. So if it looks like it's going to the VPC, route it locally. Otherwise, send it to the internet gateway so it can get to the internet. Now, in our documentation, we call this kind of VPC, the upper VPC, we call it a public subnet. So if you see that word, I put that word in quotes because it's not quite accurate. What they actually mean to say is that the subnet has a route to the internet. Because security, I'm not showing security groups in here, but unless the security group says that the thing is publicly accessible, it's not, right? But as you're reading our documentation, you hear about public subnets and private subnets. That is what they mean. Now, of course, there's a middle ground here. Like if you think about the things and the resources that you're running in that lower private subnet, it is often the case that they need outbound access. They need to reach the internet. Maybe they have a dependency on a third-party service that they reach over the internet. They need to reach outbound, but you still don't want them to have publicly routable IP addresses. You still don't intend for them to be accessible from the internet. Well, for that, VPC gives you, again, a tool of lesser privilege for internet access. That's called a NAT gateway. The way you set this up is you create a route to a NAT gateway that technically lives in the public subnet. And when the EC2 instances in your private subnet are sending traffic outbound, it gets routed to the NAT gateway. It gets routed to the NAT gateway, and you see there's a route for that. Those of you who are familiar with networking concepts, NAT is network address translation, and it's doing what you think. It's changing all of those source IP addresses to the publicly routable IP address of the NAT gateway, so they all come out to the internet looking like they're coming from the same place, tracks the connection so that the return traffic can get back where it needs to go. You didn't need to understand any of this to use the NAT gateway. If all you need is outbound access, you just set up this NAT gateway, and you have outbound, you can call the world, and the world can't call you. So, summary of the routing for least privilege part. If you do need to, if you need to take parts of your VPC off the internet, either for regulatory reasons or because you like belt suspenders and mitten clips, you can do this with routing. You figure out which parts of your infrastructure have like routing needs, which part need inbound and outbound internet access, which parts need outbound only internet access, which parts need no internet access at all, and you give them different route tables. Now, there's other things you can do with routes in VPC, including peering of different VPCs, even across account, including connectivity to your on-premises networks via direct connect and VPN gateway. It all kind of works. It all kind of works the same. And from a security standpoint, again, you're thinking about who has like connectivity needs. Which gets me to my last point. If you're trying to go even more least privilege than the least privilege techniques we've talked about for routing, this VPC endpoints part is something you're going to want to pay attention to. VPC endpoints is useful when you need connectivity out of your VPC, out of your subnet, but only to a few specific things. Here's one example where that might be the case. You're at an enterprise, you're running across a multi-AWS account environment, which today means different VPCs for these different accounts. Maybe you have a shared service account, that's the one on the right, that is maybe vending some kind of a service that you expect other accounts in the organization to have to consume. Well, there's any number of ways to create connectivity here. You can, if you have good authentication and authorization at the application level, which you should, which we're not talking about here, you could put it on the internet and access it over public IP. That's secure if you have your authentication and authorization down. You could also peer the VPCs. That kind of conjoins the network, turns it into like one network space so you can get from one to the other. Or if this is the only reason, or if this is only one of only a few reasons you needed connectivity between these VPCs, you can also create something called a VPC endpoint, also known as private link. And what this allows you to do is take that, it has to be a service running behind a network load balancer, that's our layer 4 load balancer in AWS, and you can project that network load balancer directly into the VPCs of the services that are going to consume them. And when they're there, they get this DNS name, and remember from the beginning of this talk, if I want to see where this DNS name is, I look it up and I see that this service has appeared inside my VPC. So I don't need any kind of a route if I'm just trying to get to this service that has a VPC endpoint. This is especially useful if you're running a large-scale enterprise environment with many accounts. If you are in security, you care about visibility, you care about why VPC A has access to VPC B. VPC endpoints give you a very auditable way to see exactly what everybody has access to and why. In fact, to prove to you that it doesn't require any kind of network level connectivity, I can show you this picture that I've drawn here works even if they all have exactly the same network. If they're actually on exactly the same IP address space, even then they can have connectivity like that because the service is once again projected into these VPCs. Now, VPC endpoints, they work for your own services if you put them behind a network load balancer, but importantly, they also work for access to AWS services within your VPC. What I have up here is a very common scenario. In this scenario, I'm running an application on EC2, and my application, like all applications, produces logs. Now, logs are fantastic. Logs are great for debugging, they're great for understanding how your users are using your service, and hey, they're great for security analysis. CloudWatch Logs is AWS's log service. It's a place you can ship your logs where they get aggregated in one place with great analysis tools that you can run over them. So that's great. CloudWatch Logs gives me an agent that I can install on my EC2 instances, and with just a little bit of config, I point that agent to where I expect my logs to show up, and it does exactly what you think. It shovels the logs out and sends them up to CloudWatch Logs. That's great. Okay, where's CloudWatch Logs? Resolve the DNS name, I see, hey, that's not in my VPC. That's one of these services. It's serverless. It's not running in my VPC. Okay, let me get an internet gateway for that. I can put a publicly routable IP address on each of these EC2 instances. I can give those subnets a route to an internet gateway, and now I have good connectivity. I've done my security groups right. This is 100% secure. But maybe I'm trying to route for least privilege. Okay, I'll do one better. I'll put a NAT gateway on here because I know these EC2 instances, they don't individually need public IP addresses. They need outbound connectivity to CloudWatch logs, but CloudWatch logs doesn't need access to them. Nobody needs access to them. So I've done a NAT gateway. Of course, the CloudWatch logs is still outside my VPC. If I want to go one step further than that, if I don't want any kind of gateway, any kind of route outside my VPC, that's where VPC endpoints come in. They're very easy to, it may sound like an advanced networking concept, but they are very easy to set up. This is a screenshot from the VPC console. You see, you just select the AWS services that you want access to. We support 18 of them today. That number grows over time. So here I've selected logs. I intend for this VPC to have access. I want this VPC to have access to CloudWatch logs without creating any kinds of routes outside the VPC. That's great. I set this up, and now the picture looks like this. You notice that I don't have any gateways here. Furthermore, you notice that now I'm resolving the DNS name of CloudWatch logs, same DNS name as before, but now I'm getting an address inside my VPC. And through the magic of Route 53 private hosted zones, in fact, from the different availability zones here, I'll get an availability zone local address for CloudWatch logs. So this is great. I get to this AWS service that I'm using without technically leaving the VPC. It's just worth mentioning for those of you who look under the hood at how the machinery all hangs together, our VPC endpoints for S3 and DynamoDB, they're called gateway endpoints, in contrast to the one I was showing you before, which is an interface endpoint. These two services have a gateway endpoint, exactly the same effect from a security standpoint. You don't need to put an internet gateway or a NAT gateway on your VPC to get to them, but they do manifest in a slightly different way if you look under the hood. The setup's just as easy, but you'll see you do have a route for them. You have this funny route down there that's sending traffic to a VPC endpoint. What this route means, if you have the S3 or DynamoDB gateway, if you resolve its DNS name, you'll see it's still an address outside your VPC, but it's not actually routing to any kind of a gateway. It's routing to the VPC endpoint. Same deal, just if you look under the hood, you'll see something different, and that's why. Okay, but we're not done there. This VPC security control, this network security control also is integrated with the IAM controls, with IAM policies that we talked about in the first half of this talk. So this is true for 3 of our endpoints today, and we expect the set of services that support VPC endpoint policies to grow over time. It's S3, DynamoDB, and CodeBuild are the ones that support it today, and again, you can expect to see more in the future. But with my VPC endpoint to S3 here, I can attach an IAM policy not to a principal, not to an S3 bucket, but to my network. The effect of that, and I'll show you an example of that in the next slide, but the effect of this is that I get to now use my network as a security perimeter. What this policy means, it means that any request to S3 that goes over this endpoint, that means any request to S3 that originates from this VPC, in addition to being subject to the restrictions of the policy of whoever was making the call, is also going to be subject to the policy that applies network-wide. This is very useful for governing a large-scale environment. It's a really good guardrail. So here's what a VPC endpoint policy on my VPC endpoint might look like. So you notice here, this should look familiar by now. There's a principal clause because, and again, this is not attached to a principal. It's another policy that gets evaluated along the way in an authorization. You notice that over here I'm talking about particular resources. Maybe I did that because from this VPC, I know what's running in this VPC, and I know that there are particular S3 buckets that, and maybe particular paths under S3 buckets that this VPC should be accessing it. I don't expect any other buckets to be accessed from this VPC, so let me just turn them off from the VPC. And you'll notice there's also a condition here. This is a really useful AWS-wide condition that, that we launched maybe a couple of months ago. And principal org ID, what that means is when I'm authorizing this call, I can go look at the AWS organization of the principal making the call. And he better be part of the organization that I expect. And what that means, if I have a policy like this, it means that anybody from within this network who's accessing S3, they're going to be going over this VPC endpoint, I know that this is a principal under my organization. And because I know that the policy that's attached to this principal was under my control. I know exactly what everybody in the organization can do, and I've limited use of S3 in this network only to my organization, right? This is typically what you expect. But we're not done here, right? So we talked about policy on the VPC endpoint, but there's still, as before, you have the opportunity to put policy on the S3 bucket. Now, what can you do with that? Well, what you can do with that, perhaps it's true that this S3 bucket, you only expect access to it to occur from this VPC. You don't expect access to it from anyone on the internet, even if they're signing it with the credentials of someone in your account. You don't expect access from some other VPC in your own account or some other account. You can actually talk about VPC endpoints and resource-based policies. So here's how it would look in the bucket policy. You'll notice this is the first time in this hour that we are looking at a policy that says deny. What this means in English is deny the access if it's not from my VPC endpoint. Now, double negatives can get a little bit tricky to reason about. I'm married to a lawyer. You can use 5 negatives in a sentence and he knows which way you're going. But it's hard for us normal humans. And the reason why I use the deny here is because deny in IAM is an even blunter hammer than allow. And since I'm very particular that this S3 bucket needs to be accessed from this network, what I don't want to have happen is I don't want some IAM user or role from my account, from my organization, to be trying to, maybe with a valid policy, to allow him to talk to this bucket. If he were to try to do that from outside my VPC, well, the policy says he can do it, unless I also have a deny on the bucket that says, no, I am not expecting someone to access me from outside the VPC. So that's just kind of a subtle distinction there. And then finally, coming back to what we talked about before, the role, your application running on the EC2 instance, it's running under a role. It too has policy. So we got 3 policies here. They all get taken into account by S3 as it's authorized, after it authenticates the call, make sure it's from that role. And when it's authorizing it, it's looking for all of the policies that are applicable. So you got the role policy that's applicable, you got the VPC endpoint because the call is coming through a VPC endpoint and S3 knows that. You got the bucket, which has a policy on that, S3 knows that. All 3 of these policies have to say yes in order for this access to be allowed. And like I said, there are a couple other places you can use policy. In fact, organizations, we didn't talk about this here today. If you want kind of blanket, they're called service control policies, another way to apply policy across large swaths of your cloud estate. Now, of course, you might have been watching this whole network part of this, wondering, well, who controls the network security controls? And the answer is, just like everything else in AWS, it's IAM. Typically, those permissions to create routes, create internet gateways, attach internet gateways, those permissions will typically be granted to an administrative role, someone with administrative privilege. It's something that you do not often. You don't expect most users in your account to be able to do that. So these are privileges that are typically given to an IAM user. So we've gotten to the end here. There's a couple of topics that we haven't talked about. And as you're beginning your cloud journey, I would encourage you to look into some of these topics because they're also important. They're also important and, in fact, repeated across AWS patterns for securing your workloads. Most importantly, encryption. We haven't really talked about your data in AWS, but as security people, you want to encrypt everything. AWS offers a great, simple-to-use service, key management service, KMS. It actually, I should mention that it has very good, very fine-grained permission control with IAM, and that makes sense because you would want really good control over who can encrypt and decrypt data under what circumstances. KMS is also very seamlessly and simply integrated with many of our data services like S3, like dynamodb. Often it's as simple as just selecting the key that's going to encrypt your data, and the service takes care of doing the rest. Also on the topic of encryption, this is sort of application level stuff, but important to consider as you're deploying in AWS. AWS Certificate Manager integrated with many of our services like API Gateway, like Application Load Balancer. give you certificates in AWS and take care of all of the muck of renewing certificates and all of that. Does it for you behind the scenes so you can run great secure TLS applications in AWS. We spent this whole hour talking about preventive controls, right? Permissions controls that prevent what you don't want, network security controls that prevent what you don't want. Visibility is the other side of that coin, also very important. In the cloud, you get unprecedented levels of visibility. You get visibility into your security posture like you never had on premises. The key services there, AWS CloudTrail, that's a service that we tell our customers just turn it on. Like there's really no reason not to have it on. It's a full audit log of all of the API calls that got made in your account, who made them, were they allowed or denied, what were the parameters, what was the response. And then VPC flow logs, analogously for your network. And again, you just turn this on, and you can have full, all of your traffic flows into, around, out of your VPC, source and destination, port and IP address, protocol. And you can get that dump to CloudWatch logs for analysis, or just get a dump into S3. So these are your two visibility controls on permissions and on network connectivity. And then finally, we have a growing set of higher level security services at AWS. In fact, you could spend the whole reInvent week just learning about those. GuardDuty is another one of those that we just tell our customers, just turn that on. It ingests your CloudTrail and your VPC flow logs and uses our best threat intelligence to produce findings about your security posture. Amazon Inspector, a great way to look at the patch, figure out the patch status of your hosts. So that brings us to the end here. And I hope that what you're coming away from this with is you haven't memorized all of the AWS services, but you now have the tools to know how to secure, for the infrastructure that's going to run in your network, you know how to secure the network traffic to and from it in the routes. And for everything you're going to do in AWS, you now understand the fundamental patterns, how to read and write an IAM policy, where you can apply an IAM policy, what kinds of things you can do with IAM policy. And really, the rest is details on that theme. So thank you very much. I hope you have a great rest of reInvent. Thank you for coming out for this late evening session tonight. Thank you.